tried to perform classification and detection on the SVHN dataset. So for the most part, I've relied on the original flavor of the dataset by performing additional pre-processing of the image before I do the classification and detection tasks. So I wanted to approach this problem through the lens of end-to-end deep learning, which is the idea of not having to use any handcrafted features from images to perform classification and detection, instead rely on purely doing deep learning from the get-go to the end, with the exception of image augmentation and so on. So I was also interested in trying out this approach of multitask learning, where you're trying to train a single network to perform multiple tasks. And here I've tried to train a single network with three different fully connected layers that are focused on trying to do an independent task. So the digit detector is essentially trying to figure out if an image contains a digit or not. The digit classifier is trying to figure out what sequences of numbers are present in a specific image. And finally, a digit localizer, which is trying to draw a bounding box around the sequence of numbers seen in an image. As part of the training for this, I had to also prepare the dataset by doing extensive data augmentation and improving the volume of data to support the deep layers that we have. I also had to create additional data from the Google Street View dataset to serve as the false class for the detector. So one being digits present in the dataset or in the image, and 0 being not. I was also trying to perform digit classification through multi-label classifiers. The sort of limitation here is that I predict at most 4 numbers in an image, and if you see 4 numbers more than 4, it fails to generalize across the board. Even with pre-trained weights, the performance of this digit classifier, which is trained as a multi-label classifier, doesn't perform well. If I were to repeat the experiment, I would still treat it as a single class classifier and use a different loss function. But overall, it still does the job. It does try to predict a lot of the images very well, but it struggles with images that go beyond a length of 2. Finally, there's also digit localizer, which I had to prepare the data set in a different way through data augmentation. And it works remarkably well with just optimizing it against the L2 error. So finally, the whole pipeline works with help of Gaussian pyramids to support multi-scale imaging and noise and location variance. And there is some future work that I've listed here that I plan to take on.